Okay, so let's do number 6 from the example problem packet. So this isn't the homework one, this is the other one. And so we're going to graph this negative sine function. And so really what we need to do is figure out all the stretches, the shifts, and then we can get to graphing it. So if you look at it, it's really a negative sine function. So one of the things I do to remind myself is I just say note the negative, and that way I don't forget about it later on. So we do have a vertical. Oh, by the way, also over here, this was something that we came up with in class. So I'm going to be referencing that. So the vertical stretch, well, in this case, it's a stretch. It's a stretch by a factor of 4. The horizontal stretch, if you notice, the b term in this problem is really 1. There's no b, so it's just multiplied by 1. So there is no real horizontal stretch here. It's just 1. And that tells us that the period, now the period of sine or negative sine is 2 pi, and since I'm not really stretching or shrinking it, the period is still 2 pi. The vertical shift is the k term, which in this case is 1 unit up, so positive 1. And then the horizontal shift is whatever's inside that x parentheses. In this case, it's pi over 3. And since it's a minus pi over 3, remember that means to the right. So now we've got the main things we need. And then what I tend to do is our parent function here is really negative sine. So if I do a quick sketch of negative sine, it's just like sine, but it's upside down. So it does this. Right? So there's my 1 period of sine. And normally it goes from 0 to 2 pi. And since I didn't stretch or shrink it horizontally, it's still 0 to 2 pi, with pi right down the middle. And then you can even figure out, okay, if I average those, I get pi over 2. If I average these, I get 3 pi over 2. So none of those are going to change because there's no shift horizontally, or there's no stretch horizontally. But I do stretch vertically, and normally it goes 1 to negative 1. But since I'm stretching by 4, it's going to go from 4 to negative 4. So now I've done the vertical stretch and the horizontal stretch. Now I got to do the shifts. So I got to shift up 1. So if I shift up 1, all of these values are going to change here. So the x, the y, or sorry, the y values are going to change. So my low point is, since I'm going up 1, this becomes a negative 3. This becomes a 5. So now I'm going from negative 3 to 5. Also, I've got a horizontal shift of pi over 3. So all of these values on the x-axis are really going to get moved pi over 3. I'm going to add pi over 3 to all of them. So this becomes pi over 3. I'm not going to worry about this stuff in the middle right now. Let's see. This will become pi plus pi over 3. So that'll be 4 pi over 3. And this will become 2 pi plus pi over 3, which will be 6 pi over 3 plus pi over 3, 7 pi over 3. And then you can get the middles here by doing some average stuff, right? So, oops, that's negative 3. This one was 5. So if I average pi over 3 and 4 pi over 3, I'm going to get 5 pi over 3 divided by 2. This is going to be 5 pi over 6. This will be 11 pi over 3 divided by 2, so 11 pi over 6 right here. And then you can draw the formal graph. And remember, this line right here isn't actually the x-axis anymore. I shifted 1 unit up. So this line right here is really y equals 1. So let's draw this graph in a formal way. So I need pi over 3. I need 5 pi over 6. I need 4 pi over 3. 11 pi over 6. 7 pi over 3 for 1 full cycle. Here's my y equals 1 line. I'm going to start right here. I'm going to go down to -3. So 1, 2, -3. I'm going to go up to 1, 2, 3, 4, 5. And let's see, I go down first. So down to here. Then I go back to the midline. Then I go up to 5. And then I go back down to 7 pi over 3 on the midline. So it's going to look like this. And then you would just keep that thing going. Like that. So there's our graph. There's our graph. I'll do B in another video.